25,000 feet above enemy territory, the sky explodes. Flak bursts rip open the formation. Black steel blossoms tearing through aluminum and flesh. Engines howl against the freezing wind. Oxygen masks frost over. Interphone chatter turns into shouting. Fighter at 3 o'clock, braking left. Then it happens. A violent flash. A direct hit. The front of the bomber disintegrates. Blast. Steel. Plexiglass. Gone. The nose of the B-17 is simply missing. Wind screams through the cockpit at hurricane force. Loose cables whip violently in open air. The bombardier's position is no longer there. Only emptiness and 25,000 feet of sky. Any aircraft should have snapped in half. Any crew should have bailed out. But this fortress did something impossible. For 10 full minutes, with bare control cables exposed to the freezing slipstream, it kept flying. And what happened inside that shattered bomber would become one of the most unbelievable survival stories of the air war over Europe. The aircraft shudders violently. At 25,000 feet, the temperature hovers near 40 degrees below zero. The slipstream tears through the open fuselage with the force of a hurricane. Charts, loose ammunition belts, fragments of insulation spiral into the void. The bombardier's compartment, once enclosed in curved plexiglass, is now an empty frame of twisted metal ribs. The Norden bomb sight is gone. The forward bulkhead has been ripped open like torn fabric. And yet the engines keep turning. 4 radial cyclones hammer against the thin air, their steady roar almost defiant against the chaos. Inside the cockpit, the pilots fight the controls. The yoke vibrates violently in their hands. The aircraft's center of pressure has shifted forward. Any sudden pitch change could induce structural failure. The stress on the remaining fuselage joints must be enormous. Another flak burst erupts off the left wingtip. Shrapnel rattles against the aluminum skin like thrown gravel. Hydraulics check. Oil pressure steady. The interphone crackles through oxygen masks and static. Each crew member performs an instinctive damage assessment. Waist gunners scan the sky. The tail gunner calls out distant fighters regrouping for another pass. Because the danger isn't over. A crippled bomber is a magnet for attack. German interceptors. Fast, lethal, precise. No damaged aircraft is easier prey. A single cannon burst could finish what the flak began. The bomber formation is already pulling ahead, maintaining strict combat box discipline. They cannot slow down. The fortress begins to fall behind. And now it flies alone. The pilot trims carefully. Even millimeters matter. The exposed control cables, thin strands of steel connecting cockpit to tail, oscillate violently in open air. If one snaps, elevator authority could be lost entirely. No elevators means no pitch control. No pitch control means a vertical dive. The navigator, wounded but conscious, calculates heading by instinct and partial instruments. Without a forward view enclosure, airflow distorts readings. Frost forms on exposed metal edges. Blood freezes dark against torn fabric. 10 minutes. That's how long it will take to clear the heaviest concentration of anti-aircraft fire and turn toward the channel. 10 minutes over enemy territory. 10 minutes while physics argues against survival. And yet, despite the missing nose, despite the shockwave damage, despite the freezing wind screaming through the fuselage, the aircraft remains controllable. Bare cables. Raw air. Open sky ahead. The B-17 does not break apart. It flies. And to understand how that was even possible, we have to step back to the design philosophy, the strategy, and the relentless air war that placed crews inside machines built not just to bomb, but to endure the unthinkable. By 1943, daylight bombing over Nazi-occupied Europe had become a brutal experiment in endurance. The aircraft at the center of it was the Boeing B-17 Flying Fortress. Designed in the 1930s as a long-range heavy bomber, the B-17 became the backbone of the U.S. Army Air Force's strategic bombing campaign. Operating primarily with the 8th Air Force out of England, these bombers struck industrial targets deep inside Germany. Factories, rail yards, oil refineries. Daylight raids. No darkness to hide in. The theory was simple. Precision bombing would cripple the enemy's ability to wage war. The reality was catastrophic loss rates. Before long-range fighter escort became reliable, B-17 crews flew into heavily defended airspace protected by radar-directed flak batteries and swarms of interceptors. Survival was never guaranteed. In some missions, losses exceeded 20%. And yet they kept going. Because the B-17 was built for punishment. 2. Technical strength, why it survived. The B-17's design philosophy centered on redundancy and structural integrity. 4 right are 1820 Cyclone radial engines, each capable of keeping the aircraft airborne if another failed. A massive wingspan of 103 feet. Self-sealing fuel tanks. Up to 13.50 caliber M2 Browning machine guns positioned in nose, dorsal, ventral, waist, and tail turrets, creating interlocking fields of defensive fire. But its greatest asset wasn't speed. It cruised around 150 to 180 miles per hour in formation, nor maneuverability. It was durability. Crews often said the aircraft could fly with half a wing missing, and in this case it flew with no nose. The forward fuselage housed critical systems, bombardier controls, Norden bomb sight, electrical wiring, control linkages. Severing that section should have compromised stability and directional control. Instead, exposed control cables, thin steel lifelines running through the fuselage, continued to function despite whipping violently in 200 miles per hour wind at sub-zero temperatures. It wasn't luck. It was engineering. 3. The mission, the day the nose was lost. Over Europe, during one of the high-risk penetrations into German airspace, a B-17 took a direct flak hit to the forward fuselage. Flak wasn't random. German 88mm batteries were radar-guided by this stage of the war. Shells detonated at calculated altitudes, filling the sky with timed explosions. One shell burst precisely in front of the bomber. The nose section vanished. The bombardier was killed instantly. The navigator wounded. Plexiglass and framing torn away like paper. The pilots suddenly found themselves staring into open sky where the aircraft's front once existed. Wind pressure should have destabilized the aircraft immediately. Loss of aerodynamic profile at the nose risks pitch instability. Structural failure was likely. Instead, the airframe held. The pilot gripped the yoke. Control input responded. Bare cables, exposed and shuddering, still transmitted movement to the elevators and rudder. "Controls are good," he reportedly said. Unbelievable. The crew could not move forward. The freezing slipstream made it impossible. Debris and torn metal framed a jagged opening to the clouds below. They were deep over enemy territory. Bailing out would mean capture, or worse. So they turned west. For 10 minutes, the crippled fortress flew home through hostile skies, still within range of fighters. For enemy perspective, why the B-17 was feared. German fighter pilots respected the B-17. Aircraft like the Messerschmitt Bf-109 and Focke-Wulf Fw-190 were faster and more maneuverable. But attacking a tight bomber formation was deadly. Closing from the rear meant flying into concentrated .50 caliber fire. Head-on passes were common because they minimized exposure time, but required immense precision. Even heavily damaged B-17s kept shooting. Stories circulated among Luftwaffe pilots about bombers returning to England riddled with holes, engines destroyed, tails shredded. But one flying without its entire nose? That bordered on myth. Yet it happened. And it reinforced the psychological reputation of the flying fortress. These bombers were not easy prey. They were airborne fortifications. 5. Strategic impact. The resilience of aircraft like the B-17 had cumulative strategic consequences. Strategic bombing campaigns intensified throughout 1943 to 1945. Oil production facilities, synthetic fuel plants, ball-bearing factories, all systematically targeted. The durability of the bomber fleet meant missions could continue despite staggering losses. When long-range escorts like the North American P-51 Mustang began accompanying bombers all the way to Berlin, German interceptor losses mounted dramatically. The air war shifted. Industrial output declined. The Luftwaffe was bled dry defending its own skies. And stories like the nose-less B-17 were more than dramatic survival tales, they were proof of concept. Proof that the strategy could endure punishment and still function. The aircraft eventually crossed back over friendly territory. Against aerodynamic logic. Against structural probability. It landed. Broken. Frozen. Alive. The structural integrity that saved this aircraft was not accidental. It was embedded in the engineering doctrine of the Boeing B-17 Flying Fortress from the beginning. The forward fuselage was heavily framed with aluminum bulkheads and longitudinal stringers designed to distribute stress across multiple load paths. When the flak shell detonated, it obliterated the nose section, but the primary load-bearing structure of the center fuselage remained intact. That distinction meant everything. Control systems in the B-17 relied on mechanical linkages, steel cables running along pulleys from cockpit to tail. They were simple. No digital systems. No fly-by-wire. Just direct mechanical transfer of force. That simplicity made them survivable. Even exposed to 200-mile-per-hour airflow, the cables retained enough tension to move the elevators and rudder. The pilot compensated manually for aerodynamic imbalance, using trim adjustments to stabilize pitch and yaw. Meanwhile, the remaining crew redistributed weight, secured loose equipment, and maintained defensive readiness. Because until the channel came into view, this was still a combat zone. And survival still had to be earned minute by minute. The B-17 Flying Fortress was never the fastest aircraft in the sky. It was not sleek. It was not elegant. It was built like a hammer. And in the brutal calculus of total war, that mattered. More than 12,000 B-17s were produced. Thousands never returned. Crews flew knowing survival odds were thin. They faced flak barrages that turned the sky black and fighter attacks that tore through aluminum like paper. Yet the bomber force kept rising each morning. Because machines like the B-17 could absorb punishment that would destroy lesser aircraft. The story of the bomber that lost its entire nose and kept flying is not simply about metal or rivets. It is about structural philosophy, redundancy, strength, resilience engineered into every spar and cable. Those exposed control lines whipping in open air were the last thread between chaos and control. They held. And so did the crew. Strategic bombing remains debated by historians. Its moral and military implications are complex. But there is no dispute about the courage required to sit inside an aluminum shell at 25,000 feet while the sky tries to kill you. The B-17 became a symbol, not just of American air power, but of endurance under extreme stress. Damaged aircraft returning to England were photographed and studied. Engineers reinforced weak points. Lessons were integrated into later bombers like the Boeing B-29 Superfortress. Progress in war is often written in fragments of shattered metal. The noseless fortress that flew 10 minutes on bare cables represents something larger than survival. It represents the thin margin between disaster and discipline, between panic and procedure, between falling and flying. Because on that freezing day over Europe, when the front of a bomber vanished into smoke and sky, what remained was not just machinery. It was resolve. And sometimes, in war, that is enough to bring you home. When the battered bomber finally crossed back over friendly territory, it was barely recognizable. Ground crews who watched its approach saw something surreal, a flying fortress with its entire front torn away, air rushing through a hollowed fuselage. From certain angles, it looked less like an aircraft and more like a skeletal frame held together by willpower. Yet the landing gear deployed. The flaps responded. The aircraft touched down. Against probability. Against engineering expectation. Against the violence it had endured. The legacy of the B-17 is often measured in tonnage dropped and factories destroyed. But numbers alone fail to capture what truly defined it. It was a machine built around redundancy, multiple fuel lines, overlapping gun fields, reinforced spars, distributed stress tolerances. It assumed damage. It anticipated loss. And it was designed to keep functioning anyway. That philosophy shaped the air war. Strategic bombing required persistence. Crews had to believe their aircraft could bring them home, even if torn apart. Stories like this one circulated through airfields in England, strengthening morale in ways no official briefing ever could. The bomber that flew 10 minutes without a nose became proof. Proof that structure mattered. Proof that discipline under pressure could override panic. Proof that engineering and courage, when combined, could defy destruction. Many B-17s never made it back. Thousands of airmen paid the ultimate price in the skies over Europe. Their sacrifice underpinned the eventual collapse of German industrial capacity and the steady erosion of the Luftwaffe's defensive strength. But the image that endures is this. An aluminum bomber at 25,000 feet. Its nose gone. Its control cables exposed to freezing wind. Still flying west. Still answering the pilot's touch. Still refusing to fall. Because sometimes in war, survival is not about perfection. It is about resilience under catastrophic stress. And on that day over Europe, resilience was enough to carry a shattered flying fortress home through open sky, proving that even when the front is torn away, the mission and the will to complete it can remain intact.